To Physics 2211, Lab 1 Constant Velocity by Blake Schwabe. The purpose of this lab is to explore constant velocity and the effect net force has on constant velocity in the real versus predicted world. The principles I used were Newton's second law of motion, force equals mass times acceleration, with acceleration being 0. Newton's first law of motion, object in rest in motion stays in rest in motion until an external net force is applied to that object. We want a net force of 0 to keep this constant velocity. And knowing what we learned about the real world and the many differences that are found within observed versus predicted experiments, this could lead to differences between the two types of experiments, but will give the same ideas about Newton's first two laws. Now, for the experiment I did, the equipment needed is very simple: a flat surface, a ping pong ball, a ruler, and a thumb. Step 1 is to measure a flat surface to exactly 1 meter across the flat surface. Step 2 is to set up your phone to get a recording of your ball rolling. Step 3 is to start recording and get ready to roll the ping pong ball. Step 4 is using the measurements in step 1, roll the ping pong ball across 1 meter length, and then stop your recording. Like this. And this would be the model from the observation. This is very bent, as you can see, and the reason why is there are some errors that I'm going to address later that would be this reasoning. But with code, you don't need to do that. You can just add stuff in. Like I changed delta t because I wanted to graph a little bit easier with 13 instead of 130 different ones like the original one had. And then I changed while t is equal to 1.27 to match the time of the observed motion of 1.27. And then I changed the vector position to negative 0.1 to match the speed of the first two data points in the observed motion of negative 1 meters per second. But here's the model from this code. It's a perfect negative 1 meters per second. But if you were to combine both graphs onto one, you can see that there is a very big difference between the two. But there's also some similarities, like they both start and have the same value at the beginning, 0, 0. They both have the same initial velocity of negative 1 meters per second. So what could possibly have happened? Well, in the predicted model, the ball can keep the speed throughout, whereas in the observed model, it started to slow down, making the observations difficult, especially at 0.25 seconds in. Errors could occur in this observed model, but not in the predicted model. That would be human error, as the ball could not be rolled straight perfectly. It may not be flat enough surface, so that could be an issue. Friction force being a factor in the ball's speed, which could slow it down. There could be measurement inaccuracies by the ball not being exactly a meter, or the surface not being exactly a meter. Or there could be some rounding errors with given velocities in the system, so that those two graphs would be completely different. But speaking of which, what if? So right now, the position axis that I had was negative because in the video I showed you, I rolled the ball right to left, which is more known for negative velocities because of graphs that we've shown as kids. But if I were to switch the axis to positive, speed would stay the same because it is a scalar, but velocity would not because it is a vector, and it would flip to positive motion instead of negative motion. But you may be asking, what does this all mean? Well, within the computer program, you can set net force to 0. But in observed motion, you can't do that yourself. But there are forces that act in your system already that you may not know. There's normal force from the table up to the ball, and then there's gravitational force that goes downwards from the ball onto the table, which are both equal to each other, making that net force 0 in the up and down direction. But there's no outside force on that acting on the ball from opposite directions besides one, friction force that I could not take out within this because this is the friction that I had was not perfect. But if there was a surface that had 0 friction that I had, then there would be a perfect 0 net force on the ball, and you can see constant velocity. Now, there will be some errors still within that, but it would be a much better system than what I have right now. So, with that all being said, thank you for watching.